Hello guys, how are you doing? Welcome to this video. We're gonna talk about C++ variables and its type, scope, and a little bit about its lifetime. So yeah, let's start. First of all, I want to talk about the setup. I'm using the WSL Windows subsystem for Linux. Now we are on a virtual machine and accessing the files through the WSL extension. And we're gonna use the GCC compiler. Technically, we're gonna use the G++, which is like a front end on top of GCC to allow us to compile C++ files. Before talking about variables, let's briefly talk about the common things you're gonna always see in a C++ program. First of all, using namespace std. So a namespace is to avoid naming collisions. Uh, it's basically if you check the GCC, for example, source code, it's something like that. Namespace, sorry, namespace std. Uh, Curly braces, and then it includes the variables and functions. Most of the standard libraries identifiers exist uh, uh, in this scope. So like cout, cn, string, etc. So basically the compiler prefix all, for example, cout, it's prefixed by std scope operator. So if just for learning purposes, because some people advise not to using namespace std, but for learning purposes, we're gonna use it to avoid prefixing every standard library variables or yeah or object technically. So yeah, and what else? The integer main. This is like the first entry to any C++ programs. It's a function act as the first entry to the program. Cout to print data to the screen, as you can see. Hello from the other side, and return zero. Basically, because usually functions return something, but since it's the first entry in a C++ program, so we're gonna return zero. We're gonna return nothing. So, also, the header files hash includes iOS stream. It includes the declaration for cout and cn to accept inputs. Hash includes string in case you want to use the string data type, which we're gonna see it later. Uh, this double slash mean a comment in C++. So yeah, built-in types. First of all, we have int. Int stand for integer. It's for storing integer positive or negative numbers. Second, the float. We have a float. Float. It's called like that because the comma we call it floating point. Because it moves left, right. So yeah, that's why it's called float. So to use the fractions like 2.5, 2.6, and so on. Double, now double the same as float, but the size is different. It's the double the size of float. So this the why it's called double. I guess it's 8 byte. A float it's 4 bytes, so 32 bits, leaving the most significant bit on the left for the positive or negative. It's 0 for positive and 1 for negative, and so you are left with 31 bit to represent the number. And we have what it's called bool. Bool for a boolean. It's in the boolean algebra. This is the name called bool for storing logical values. What we mean by logical values is like true or false. So, for example, condition true, true, or we could false. Yeah, that's it. Now for char for character, to store a character, for example, let's say copy key or copy button, whatever you want. We use a quotation. Yeah. So remember to end every statement with a semicolon. This is the way how C++ works. Also, we have string. This that's what I was talking about, the header, the string header. If you want to use a string, for example, let's say name and double quotation. So yeah, that's how to write a name in C++. You include it within a double quotation. Also, there's something called a type modifier. So type modifiers, the most common are sign, unsigned, long. So long modifier, for example, it's uh, to increase the size. Let's say you have I don't know, like a distance, and it's a big number. So you use long to store a big number integer. So you, for example, you say long integer distance, let's say. Also, you can use multiple modifiers, as I said, for example, sign. But here it's redundant because integer by default is either positive or negative. So yeah, I mean sign. So no need to put sign. Yeah, that's it. And unsigned, just in case if you want to use just a posit to make sure the variable won't store negative numbers. Yeah, I mean, like it's a, like a length or something. Length, for example, always the value, so you could use unsigned integer something. Let's now try to compile and run the program. Let's say cout a uh, and L to put a line. So the next line would be on new line. So yeah, this is called end line. And now let's try to compile. As I said, we're gonna use the GCC and G++. It's on top of GCC to compile C++ file. So this how you do it. G++ option O for output, and you call variables that out, you whatever you want to call it, the executable file, and then variables.cpp. So let's try to run it. Yeah, now if you want to execute it now, it has been compiled and linked with the standard library automatically. This command do all this stuff. Now to run it, that dot for the current working directory, then we call variables dot out because that's how what we name it. Press enter. So yeah, this is yeah, we forgot to assign a value to integer a. That's it give us, we call it a garbage value or random value. We didn't give it a number. Now it's if we give it like a number and we recompile it, then we run it. So yeah, this cout2 and cout the sentence on a new line. This backslash in backslash is like a escape letter, and n stand for a new line. So you could use this or you could use end line. A float. Let's try to, for example, float 2.5, right? And cout b. Again, recompile it, rerun it. Yeah, that's it. Also, I want to talk about naming variables in C++. So in C++, there's some rules. First rule, start every variable should start with a letter. Second rule, C++ is case sensitive. So what we mean by case sensitive? Let's assume you are a developer in FIFA, in EA, right? And they told you to create the foot card player. So you want a variable to store a name of the player. So let's say player name. So player name is different from string player. For example, name. Yeah, or player name. Because the first one is capitalized, in this one it's not capitalized. Yeah, even if like that, this is different than this one. Yeah. Also, variable should not be a keyword, not a keyword. Keyword, we mean by keyword uh, that it has a special purpose in C++. For example, integer main, you cannot call a variable main, or float, double, etc. Or a string, for example, cout, cin. These are not allowed. Also, try, guys, to follow a naming convention and be consistent with it. Now you have a multiple naming convention. For example, personally, I love camel case. Camel case, you start each word with a capital letter except the first word, as written here. Or snake case, this also popular in C++. Snake case, you use the underscore. And yeah, that's it. Scope in C++, each variable has a scope. A scope, it's where it can be accessed. So we have local scope. Also, we have a global scope. We have a namespace scope. We have a class and file scope. Now the last two is out of the scope of this video, no pun intended. So we're gonna talk about them later, let's say, hopefully in other videos in the future. Now we're gonna discuss the first three. So local scope, for example, these variables all have a local scope. Local scope means with respect to this function. It's local with respect to this function, so you can access it anywhere after its declaration here in this function. Now, for example, global scope, if you declare it outside of uh, the function, outside all the function, for example, here under the naming space or the including header directives, this is considered a global scope. Global scope. If we had like a second function here, you could access this variable in this function here. For example, an adder function to add numbers. For example, this a, it's a scope only within the main function, so you cannot access the main a from the adder function, but you can access the global a from the adder function. Yeah. Also, yeah, I just want to mention global scope. Also, sometimes it's called the global namespace. So it's, you could consider it as a namespace scope. Now, the namespace scope, if you remember, guys, I talked about using namespace std. That if you didn't include this directive, you need to prefix each standard library variable or object with std. So for example, cout, you will need to say std, this we call the scope operator, then the identifier name cout, for example. But since we included the directive using namespace, the compiler automatically would prefix the standard identifier with std. Usually namespace scope good to use it when you want to create a library. To avoid naming collisions, right? I mean, you could have a variable called x, and you use another library also it has a variable called x. How the compiler gonna distinguish between your library x and another library x? You would use a namespace. You would declare them in a namespace. For example, math. Let's say math namespace dot double column your x. Another another library would what whatever. Another library could use the namespace, for example, direct x, for example, double column, whatever, right? So this is the namespace scope. So guys, we are talking about global scope and local scope. So here there's something. If let's say we want to access the global scope variable a from the main function. How we could do this? There's an operator called the global, sorry, the scope operator. So let's say try to this double column. It's called the scope operator, and you keep empty. You don't use any name. This basically means the global scope, and you put a, right? So now let's try and compile this program. So as you can see, 5, it's the value of the global A, and 2, it's the value of the local A, of the yeah, of the local scope A. So yeah, because the thing is, by default, the nested scope take a precedence over the enclosing scope. Think about it in this way. This is a nested scope inside the scope of the global scope, right? The main scope is nested inside the scope of the global scope. So if you write only A, by default, the compiler gonna understand that you want to access the local A. So to use the global scope A, you use the global operator. Next, we're gonna talk about the lifetime, variables lifetime. Lifetime. We have three types. We have stack, dynamic, and heap dynamic. Third one, static. So stack dynamic, it's called stack because the variables are stored in a memory location called stack, like a stack of books. Second one, it's a heap dynamic, also a kind of memory storage called a section of memory called heap. Now dynamic because the allocation of storage it happens at runtime, while static the allocation of storage happen at compile time. So now all these variables are stack dynamic, right? When we call this function main, the on the call stack, all of these variables would be stored on the call stack. Now for heap dynamic, even though it's outside the scope of this, but we're gonna talk about it briefly. For example, we have what is called pointers. Hopefully in the future we will discuss it in details, but just a brief look. Let's say integer star b, we call this pointer, and we use what is called the new the new operator integer, now initialization 5. So this is a pointer to a storage allocated at the heap, and later if we want to destroy it, we could destroy it using destroy b. Yeah, so the thing is, the stack dynamic lifetime is automatically at declaration time. it gets stored in the storage, right? And at the end of the block where it's defined, its storage would be deallocated. So now all these variables, when we reach the end of the function, they're gonna get deallocated, right? So we're gonna free the storage from them. In other words, a heap dynamic, we call this kind of variables explicitly allocated and deallocated because you decide when to declare them, when to bind the variable to a storage, and when to free the storage from the variable using the new and delete. Sorry, actually, not destroy. Delete. Yeah. So yeah, delete operator and static. Now, static. The lifetime of static is the lifetime of the program. So it's it starts at the when it's declared, right? Where it's declared and stays until the end of the program. So you could define a static here, for example, integer static name, right? Or counter. Or you could define it here, for example, let's say here static string name. Usually we use static, for example, also in the future when we talk about recursive functions. Let's say because a recursive function is a function that call itself. But let's say we want all these functions that are getting called repeatedly, right, to access a shared variable, so to speak. So we could define a static variable, right? So we're gonna discuss it later in more details. So yeah, that's it for the lifetime of variables. I'm planning on continuing this series. Let me know if you are interested in more videos on C++, or maybe you have another subject like JavaScript or React. If you like the videos, give us a like and subscribe to see my upcoming videos. See you guys in another video.